Here are solutions to quiz number 3 for ECE 320. The first problem is the same problem that you had back in quiz 2, but now solved using ideal diodes. With an ideal diode, the diodes are either on or off. So the challenge is figuring out which ones are on or off. So I've got 10 volts trying to push current this way. Probably diode 1 is on, probably diode 2 is on, probably 3 is off. So let's assume that on, off. That makes it pretty easy. I've got 10 minus 0.7, the voltage drop across the silicon diode, gives you 9.3. 9.3 minus 0.7 gives you 8.6. And this one's off, so ignore it. B4, I don't know, so I have to solve using voltage nodes. At node 4, the current left, current up, current right, and current down equals 0. Current right is 0. The diode is off. So I have B4 minus B1, B4 minus 9.3 over 100, plus B4 minus 8.6 over 200, plus B4 over 400 equals 0. Solve, I get V4 is 7.771 volts. Then B3 equals B4. Again, the current is 0, so this voltage drop, I times R, is 0. V3 equals V4. So there's your voltages. And as a check, if this is 7.7 volts, this is voltage going backwards, that turns off that diode. Problem 2 is another problem from quiz number 1. Again, solved assuming ideal diodes. So again, I'm trying to push current this way. So it looks like diode 1 is on, diode 2 is on, diode 3 is off. If this is on, I know the voltage V2 is V1 minus 0.7. This is V1 minus 0.7. Now do a supernode. Here's my supernode, the current left, which is V1 minus 10 over 100, plus this current, V1 minus 0.7 over 200, plus this current, V1 minus 0.7 over 300 equals 0. Solve for V1, I get 5.733 volts for V1. V1 minus 0.7, V1 minus 0.7, and V4 is tied to ground. Problem 3. If I build this circuit, what happens? Well, I've got a red diode and a green LED, or red LED, green LED in parallel. Only one of them will turn on. This will be the smallest. If the red diode turns on, this is 1.9. That's not enough to turn on the green LED, so the green LED turns off. I'll then put these two resistors in parallel, which is 567 ohms, and then find the current. It's 10 volts minus 1.9 volts over 567 ohms. That's the current through the red LED. That's 14.26 milliamps. And then the brightness. 100 milliamps is 5,000 millicandles. This is that percentage of full current, that percentage of full brightness. 71 millicandles. I think this slipped a decimal point. 713 millicandles. Problem 3. Number 4. The frequency is 1 over the period. The period is this distance, 3.25 milliseconds. 1 over that is 307 hertz. The peak is 11. The minimum is 5. The average is 8 volts. So there's your DC level. The difference is your AC level. The difference is 6 volts peak to peak. Number 5. If I have this AC to DC converter, to find the voltages, I do both DC and AC analysis. At DC, I know V1's going to look like this. The peak is about 19.3 volts. That's the 20 minus 0.7. The current I don't know, so let's do worst case. 19.3 volts over 300 plus 1314 is 11.97 milliamps. From I equals C dV dt, I can find the ripple is 99.7 millivolts peak to peak. The DC level is the peak minus half the ripple, 19.25 volts. So there's the DC voltage, and the AC voltage is the peak to peak. Once I know V1, I can find V2, At DC, it's just voltage division. R over R plus 300 times V1 at DC, 15.67 volts. The AC voltage, put these two in parallel, 184 minus J456 ohms, and voltage division. There's the in parallel over parallel and the resistor and inductor times the input, which is this number right here. Multiply it out, take the magnitude, 32 millivolts peak to peak. So there's the DC voltage at V2 and the AC voltage. The last problem, I want to find C1 and C2. And I want it so that this is 5 volt peak to peak ripple. And I want this to be 1 volt peak to peak. Well, first find V1. If the peak is 19.3 volts, again I lose 0.7 right here, so V1 looks like this. The peak is 19.3, the bottom is 5 volts below that, 14.3. The DC level is the average. DC level is 16.8 volts. From that I can find the current. 16.8 volts over the total resistance is 10.42 milliamps. From I equals C dV dt, I can find C1. C1 should be 34 microfarads. To find C2, the approach I like to use is assume C2 equals 0 and find the voltage at V2. So that'll be, the AC voltage will be your 1314 R1 over R1 plus R2 times the input, 2.6 volts peak to peak. I want it to be 1 volt peak to peak, so that says the capacitor needs to reduce this resistance by this ratio. I need to drop it down to 496 ohms. So roughly, I would pick C to be 5.34 microfarads, so that 1 over J omega C is 496 ohms. It's actually minus J 496 ohms. And that'll get you close. If you wanted to, you could iterate. Given C2, recalculate the ripple, readjust C2, keep on going. And after about 3 or 4 iterations, you'll wind up that the actual value of C2 should be 7.95 microfarads. This gets you close. If you want to get more accurate, throw it in Circuit Lab, or you could iterate if you wanted. That's not necessary. So that is quiz number 3 for ECE 320.